This is problem 4 from the Chapter 5 closure packet. Solve each equation after first rewriting it in a simpler equivalent form. So part A. First thing we notice is we have some parentheses here on this left side of the equation. So let's distribute this 3 to the stuff on the insides of the parentheses, which distributing means you're going to multiply. So 3 times 2x is 6x, 3 times negative 1 is negative 3, and then copy down everything else. Okay. So we just distributed the 3. Next, let's combine our like terms. So on the left side, we have negative 3 and 12 that are both just regular numbers. So I'm going to combine those together and copy everything else down. So those two numbers, negative 3 plus 12, gives me positive 9. And copy everything else we didn't touch yet. Okay. Then we need to get the x on one side and all the other regular numbers on the other side. So I'm going to subtract 4x, because that's the opposite of positive 4x. I'm trying to make those not be there. I'm trying to make this become 0. So this goes away, because 4 minus 4 is 0. And then let's write what we have left over. This will give me a 2x, copy down the plus 9, and then the minus 3. So now this side is where the x's are. I need to move this positive 9. So the opposite of adding 9 is, let's subtract 9 from both sides. We're always doing the opposite of things. Okay? So these go away, and I'm going to write down what comes up here, what happens next up here. So 2x equals negative 12. So negative 3 minus 9 gives me negative 12. Last thing I need to do is get the x by itself, so I'm going to do the opposite of multiplying by 2, which is dividing by 2. So x should give me negative 6. That's for part A. Okay. Part B, we have some fractions here. We have this first term is divided by 7, this term is divided by 7 as well, and then I have a 2. So instead of dividing by 7, the opposite of that is multiplying by 7. So I'm going to multiply each term here by a 7. And I'm going to show you a little step by step. You might just go right to the next part, and you might not do what I show you, but this is hopefully to help you realize what's happening. So multiply each part by 7. So 7 divided by 7, that goes away, that's worth 1. So this 7 and this 7 on the bottom cross out. So all I have left is this 3x. Okay. Then I have this term, 2/7 times 7. If you're not sure, that doesn't have an x in it, so you can really type that in your calculator. But 7 divided by this 7, those are worth 1, so those 7s go away. So I just have a plus 2 left over. Okay. Then the last number, 2 times 7, there's nothing, it's not dividing by 7, so you just do 2 times 7, which is 14. Okay, so to get rid of those fractions on the bottom, I just, instead of dividing by 7, I multiplied every single term by 7. Now I have a much easier equation to solve. So now I'm going to subtract 2 instead of adding 2, because that makes it go away. 3x equals 12, and I'm going to divide both sides by 3. So x equals 4. So that's for part B. Okay. Part C, notice I just have one fraction on the one side equals another fraction. Most people like to cross multiply when they see this, and we can do that. You can't do that up here in part B because I don't have one singular fraction. You could have added these together because they had the same denominator and then cross multiplied, but it's a good strategy because these might not always be the same exact numbers, so just multiply. So when we're here, we can cross multiply though. So that just means top times the bottom one, this top times the other bottom one. Okay, so 5 times x minus 3, I'm going to write that out. 5 times x minus 3 equals 3 times x, which is just 3x. Same thing we did in part A, we're going to distribute this 5. So 5 times x is 5x, 5 times minus 3 is minus 15, equals 3x. Copy everything else down we didn't touch. So we got x, number x. I'm going to move this 5x from this side, so then the x's would be on the right. Okay, so those are gone, so we bring down the minus 15. This equals negative 2x, 3 minus 5. Then I'm going to divide by negative 2. So make sure I have negative 15 divided by negative 2, which is worth positive 15 halves, or 7.5, or 7.5. Either one of those is okay. Okay. Remember, you can check all of these answers by plugging them back in. You can plug in 4 for each of the x's in this part B and see if it is a true statement. So you can always check your answers on these equations. All right, D, we have a couple sets of parentheses going on. The left side I'm going to distribute just like I have been. The right side, we're going to draw a generic rectangle. So left side, 4x times x is 4x squared. 4x times minus 2 is minus 8x. Make sure you bring this x over here with it. And then we have the right side, draw a rectangle. And we want to find the inside, the area of the sum, which is all the insides added together. This is area as a product right now. So I multiply to get each of these insides. Okay, so that's what I have on the insides. I just multiplied them together. So I'm going to combine all of these together and add them all together. So I have 4x squared, this 2x, minus 6x gives me minus 4x together, and then write minus 3. So we just put them all together like in one line. Equals, I'm just copying this other side down. From up here, just copied it down here. Okay, so now we want to get all of our x's on one side, just like before. So notice they both have a 4x squared. If I subtract 4x squared on both sides, they both end up going away. So that's fantastic. Okay, so I'm going to copy all of this stuff over here now. So remaining on the left, we have a minus 8x. Equal sign. Remaining on the right is minus 4x minus 3. All right, so I'm going to move this minus 4x over to here. So to do that, I need to add 4x, opposite of subtracting. So I get minus 4x equals minus 3. Make sure you're careful with those signs. Last step is divide by negative 4. So you get x equals positive 3/4 or 0.75 is okay for that too. Okay, so that's A through D. We have one more. Next page here. One more, part E, is we have absolute value. Okay. So we need to get that absolute value all by itself before we can start doing stuff with it. Let me write that down. We need absolute value alone. Because then we make two equations for it, if you remember that from, I'm not sure what chapter that was, but this is all old ideas right now. So first thing I need to do is get rid of this 2. I'm going to work my way outside in towards the absolute value. So instead of adding 2, just like the other problem, subtract 2 first. All right, so we have 3, absolute value of x minus 5 equals 6. Okay. Then I need to get rid of this 3 right here. Well, since it's touching the absolute value, it really means multiplying. So instead of multiplying by 3, I'm going to divide both sides by 3. So now this 3 and this 3 cross out. That's worth 1. 3 divided by 3 is worth 1, so it can go away. So now over here we have x, or the absolute value of x minus 5 equals 2. All right, 6 divided by 3 gives me 2. This point, once I have the absolute value bars all alone, there's nothing on either side of them, then I can make two equations. Now you draw 2 arrows, make 2 equations. So x minus 5, that stays the same for both of them. That's the same. What changes is what it equals. So inside here, the absolute value of something that has to be 2 spaces from 0. Well, something 2 spaces from 0 is positive 2, and something 2 spaces from 0, negative 2, is still the same distance away. So now I have 2 little equations to solve here. So if I add 5, I have x equals 7 as one possible answer, and notice it's not just going to be x equals positive 7 and negative 7. That's not what always happens. So add 5 still in the other equation. I'll get x equals positive 3 as my other solution. So I have 2 answers for absolute value problems, but you have to get the absolute value bars by themselves first in order to do that. So ask your teacher if you still have questions on this problem.